Okay, let's move on to page 2 of our properties of integrals thing. You've got two graphs on that page and then a bunch of little integrals on the bottom. So let's walk our way through this. So the first function you've got is f of x equals x. That's graphed right here. And you've got g of x equals 3x. Those are cleaner and prettier on the handout if you actually bothered to print that thing. So I just want to integrate. So for the first thing, I want to integrate the f function from -2 to 0. So we're basically just finding the area of this red little triangle. So that has a base of 2 and a height of -2. So this should just be half of 2 times -2. That should be -2. That's it. It's the whole thing. Now we want to do f from 0 to 4. So that's basically just this green rectangle. So that should be 4 by 4. So half of 4 times 4. That should just be 16 cut in half. That's just 8, and then we're done. And then we want to go all the way from -2 to 4. So that should just basically be what the red triangle was plus what the green triangle is, and we just computed those like 3 seconds ago. So that should just be -2 plus 8. That should just get us 6. Ta-da! That one's done. Next, we basically ask the exact same, or I ask, the exact same 3 questions, but for this new function g of x, which is 3x. And we basically just have this taller upside down triangle, which is still 2 wide, but it's 6 down. It's negative, so it's down. So we should just be doing half of 2 times -6, which is -6. Then we want to do this one. This big giant triangle, when we integrate this guy from 0 to 4, that should be, that's 4 units wide. This should be 4 times 3, so 12 units tall. Half of 4 by 12, which should be 24. And then the last thing is basically the same question, which is -2 to 4, but this time for the g function. So that should be 1 upside down red triangle plus 1 great big tall right side up tall green triangle. That should just be -6 plus 24. That should be 18. Now, hopefully you notice the pattern. There are 2 key important properties that I'm trying to highlight when I do this particular setup. Property number 1, I guess. They're not really numbered, but property number 1. The only difference between the g function and the f function is that it's the same function, x, x, it's just that one's getting tripled. So surprise, surprise, the answer to this is 3 times bigger than the answer to this. 6, 18. That's a 3 to 1 ratio. This is 3 times bigger than this. This is 3 times bigger than this. That's it. It's 3 times bigger because of that constant. It basically makes the height of all those infinitely little skinny little rectangles 3 times taller. And if all the heights are 3 times taller, then overall the answer is going to be 3 times bigger. The second little property that I want to highlight is basically if we're integrating from -2 to 4, we can split that up. We can go from -2 to 0, and then from 0 to 4, and then just add those 2 answers together. I think this is probably one of the more common sense properties of integration. So here's our big summary of these properties that we're getting from this page, the hopeful big takeaways. So, big takeaway number 1 is if you want to integrate from a to b some function f of x, you can start at a, stop anywhere you want, c, and then just start over again at C, and then stop at B, and that'll do it. So integrating from A to B means you can integrate from A to C, start over for the second integral at C, and then make it all the way to B. The other property that's important is that if you try to integrate a constant times a function, you can just multiply the constant times what the function is. It basically this k just makes all the areas k times bigger. In our case, k was 3. It makes all the rectangles 3 times bigger. This is you finding the area of all the rectangles and then tripling them at the end, gonna give you the same result. So constants can come through the integral symbol if you want. That also is true of antiderivatives, and you'll hopefully notice a theme for the properties and when they're true for integrals and when they're true for antiderivatives, almost like they're somehow related or something like that. So that takes care of page number 2. New video coming up for page number 3.